Okay guys, so this is my machine after the last upgrade. Just I changed the rails on the x-axis to the fully supported type of rails here, SBR 16, and now the whole machine become really sturdy and it's milled really nicely on anything like plywood, MDF or aluminum. But for the long-term use of this machine, I also want to upgrade the stepper motor, so I already pre-installed them on here. I don't know if you noticed from my previous videos, but I changed them to this type of a stepper motor, just a bit bigger, so they'll require 2 amps on each stepper motor. But right now I still use the old control board with the old stepper motor driver. They only can like supply only like 1.4 amps for each stepper motor, so I cannot really use the stepper motor to the full potential. So what I decided to do today, just I will change the control board and the stepper motor driver. I'm just going to take the chance to change the control board to something is Mach3 compatible, because for me I think Mach3 is a bit more mature compared to Gerbo, and you can do a lot of like programming for the macros and buttons and customize things. So that's what I'm going to do. So the next step, I'm just going to design a board at the back here so I can attach all the components on it, and it will be neat and tidy. So let me just do that and show you all the wiring and setup on the computer. I think that I have everything I need here to do the stepper motor upgrade. I have the power supply, 36 volt, 10 amp, the stepper motor drivers, TB 6600, it can go from 9 to 40 volts DC, and the maximum current is 3.5 amps. So though are more than enough to drive 3 stepper motors, NEMA 17 2 amps, so the total of 6 amps. And for the control board, you have 2 options. The first option is to use the original control board of the 3018 CNC, and to connect this board to those stepper motor driver, you will need to take out the original stepper motor driver here and replace them with this type of module. You just plug them in and connect the pin from here to the corresponding pin on the stepper motor driver here, and that's it. My option is to use this board. It is Mach3 compatible, and I bought it on AliExpress for only $15. It comes with this compact disc, just have the software and then also the plug-in for this board and also this USB cable, so it's fairly cheap. My next step is to install all the components here on this plate and attach this plate to the back of the 3018 CNC. I'm not going into details of this part because you might use different type of component, different type of stepper motor driver, control board or power supply. So you can just customize this board the way you want. For me, I make all the holes here to arrange all the components the way that I have access to all the pins here and secure all the wire very easily, and that's it. So I just going to install all the components on here very quickly and show you how it works at the end. Okay, so I just saw that this board needs like 24 volt input here. So what I'm going to do is I'm going to use a DC step down here and adjust it to 24 volt from 36 volt and power it in here. And to install this, I'm not going to do anything fancy, just mounting tape and tape it down here. I think just I'm done with the wiring here, so let me just install this unit on the machine and explain a little bit how things were connected. Let's just take a look at the back of this machine. Just I have everything wired here and arranged a little bit. On this side I have the speed controller for the spindle, and this is the power supply for the spindle, and here's the power supply for the stepper motors. The PWM signal to control the spindle speed is come from the output one of this board. Just I will show you how I configure it on the computer. And the way I wire the stepper motor driver is just all the enable plus, direction plus, and post plus. I will connect it to 5 volts, and the other 2 pin like direction minus and post minus will go the corresponding direction and post pin on this control board. And I have here the touch probe is connected to input 2. Other than that, I don't think that there's anything else that really need to be connected here. Let me just show you how I configure the board on the computer. I just copy the whole compact disc into this folder. So here I have a bunch of PDF. I'm not going to read it for now. So I'm just going to go to Mach3 software. I think that is the folder. Then in here I have Mach3 and Mach3 software. I'm not sure. Just go to Mach3 software. And I have another Mach3. Okay, so here I think this is the installation file. I think that's it. So I just going to click next. Yes, next, and install. Okay, it says something here. I just click OK. So yeah, not much I can do. Okay, so here I just going to uncheck this. I'm not going to use lazy cam. I'm going to use Fusion 360. That's it. I just click finish, and it says no driver sense installed. Run drive test. So just click OK. Nothing I can do. Okay, so it seems to be done. And I think I have to install the license file. Here it says just copy it to the Mach3 folder. So I just copy it. I guess I just put it here. Now I have to go back to that folder, and then I think I have to copy the plugin files. It will be R&R Motion. That's what I got. So just copy it and go back to Mach3 and plugins. I just want to paste it here. Okay, so now I think I can run Mach3. So I just do copy of the Mach3 mill, and new profile name I'm going to do it like 3018 CNC, I think, and I click OK, and then I just highlight it and click OK. So here I just going to choose this board and don't ask again. Okay, so here I have the Mach3 ready. I just going to follow all the guides that I found on internet to configure this board. So Google, and I'm going to do R&R motion board, and I'm just going to click on this one. Okay, so I think that I found the right website, and I just going to follow all the steps just showed in here. Okay, so here I just click on config, ports and pins, and then disable this. I'm just going to keep everything else the same. Motor output. So here I think I had to change everything to 0 according to the guide. And spindle to enable. Step pin is 1 because I have it on the output 1, and step port will be 3. Here, well, I don't have any type of a limit switch or homing switch, so I just leave it the same. Go down and I see probe, so I'm just going to enable it. Port number, I put it on number 3, just the input, that's what they say. And pin number is 2 because I put it on the input number 2. And I think that's it. Output signal, I have the spindle number 1, port will be number 3, pin number 1, and that's it. I'm not going to change anything here. Go to spindle setup, and I'm just going to disable spindle relays, and I'm going to use PWM control, and this I'm going to put 1000. I think that's it. So I just click on apply and OK. And here now I'm just going to go to motor tuning. So for the X and Y axis, I have the lead screw is 4mm lead, and I configure all my stepper motors to 1600 micro stepping. So here I put 400, and for the speed here you will have to do it multiple times until you find the speed just is the fastest and it doesn't make your stepper motor lose step, and then you probably take like 10% less than that, so it will be whatever. I want to put 3000 for now, and then I will try to configure it later. And acceleration I'm going to put like 40, and save axis setting, and go to Y axis, do the same. On the Z axis I have like 2mm lead screw, so I'm going to put 800, and this I will go a bit slower because on Z axis is a bit heavy, you have to lift the spindle up and down, and this I will do like 35 and save and click OK. Next step I just going to go to spindle, and here I change it to number 1. Mean speed is 0, maximum speed is 12,000, and that's it. If you want to jog, you just press on tab, so this kind of like button just show up so you can jog it around. But if you don't want to use these buttons, you can also use the keyboard from your computer. So you just go to config, system hotkeys, and you can configure all these buttons to whatever key you want, so make it faster, like moving X, Y, Z up and down, and well, to the position what you want to set the references, and click OK, and that's it. I think that's about it. But now you probably ask what's better about Mach3 compared to Gerbo and Candle. So what is better here, just you can configure all the button here very easily. So to do this, you just go to operator and do edit button script, and you see when it's blinking like this, all the buttons just you can configure. You just click on one, for example the auto to 0. So in here you can just program it, or you just go on internet and find a script just already work and paste it in here. Here in the settings tab, it's very easy to calibrate all the axes. You just set steps per unit. So choose one of the axes and tell it how much it's moved. And then after that you can just enter the number, like for example if it's moved like 102mm, you just click on 102, and Mach3 will calculate the new number by itself, so you click yes, and that's it, it's calibrated. And here in offset tab you can also configure multiple buttons to do all type of probing and things. And also if you remember the backlash gap that I showed you in previous video, you can also compensate for it very easily in here. Go to config and backlash, and here you only need to put in the number on each axis, just how much you need to compensate for it. So click OK. And another thing just I think is very helpful is just you have the function config here. You go to formula, and here you can enable it. For example, if your X and Y axis are not orthogonal to each other, you don't need to like modify the machine physically. You can do it by the software. So you can enter something like X equal to X minus Y multiplied by some number. This number I show you how to calculate it in one of my previous video about 3-axis CNC calibration trick for high precision cutting. So you can just follow the guide to find out how you get this number and click OK. So in this regard, I think Mach3 is better, it's more professional, and it can push your machine to the limit. Let me just show you how all the axes move after all the configuration of this software. Okay, so after playing around and set all the parameters, let me just show you how all the axes move. I'm just going to use the keyboard shortcut that I configured to jog it. All the movement I showed here are in real time. I didn't speed up at all, and as you can see that it moved really fast and smoothly, so no problem at all. So those stepper motor just help to accelerate all the speed in all axes, so make it faster. And if you have any problem on any axis that is moved in the wrong direction, you can just swap the wire on the stepper motor driver very easily from channel A to channel B, and then the direction should be swapped. And I just also found on internet a script for the Z-axis tool probe, so I'm just going to show you very quickly. The setup is the same with the previous setup on the 3018 CNC. Okay, so here I just click on the Auto Tool 0. The Z-axis probing were done in two steps. First step is roughing, so it goes down really fast. When it starts the aluminum plate, it just go up a little bit and then it go down very slowly until it touch again. So the second time will be very precise because it go very slow. And then it go up again 5 mm for clearance. So now you can just clear up the tool probe setup. I will share this script in a text file if you want to use it. Let me also just show you if the spindle works correctly. Well, as you can see that the speed vary very nicely, no problem at all, so it works as before. Some of the viewers just suggest to me to do 3D adaptive clearing on aluminum milling, so that's what I'm going to try and show you next. Okay guys, so as you can see that it cut really nicely. Everything is smooth and shiny. The feed rate was 600 and the maximum step down was 0.3 millimeter. So there wasn't much of chatter, sound or vibration. So adaptive clearing definitely the way to go to cut aluminum on this machine. Okay guys, so the new bigger stepper motor definitely have to move things a bit faster, and it will save some time in your cut, especially when you use some tool path like adaptive clearing, where there's a lot of like fast movement and change directions. And also the change to Mach3 will give you a lot of potential to customize the machine, and also it makes the use of this machine a lot more pleasant. And this upgrade is very easy. You can definitely do it on your original 3018 CNC. You only need to swap out the stepper motor. You can still use the original stepper motor mount. Well, just add on the stepper motor driver, the power supply, and that is about it.